Okay, so today we're going to be going over the parent functions of tangent, cotangent, cosecant, and secant. Okay, so just like we did for sine and cosine, we're going to use values from the unit circle of tangent to give us our parent function. Okay, but there's only going to be certain values that we're going to be able to use that are going to be valuable to us. Okay, just like sine and cosine, because there's going to be values like the square root of 3 over 3 for tangent that we're not going to be able to use because it's going to be in between numbers. So just like sine and cosine, for tangent, we're going to start at 0. So when x is 0, what's tangent at 0? Well, that's 0. So we start at the point 0, 0. Okay. Then we're going to move to pi over 4. What's the tangent at pi over 4? Well, that's 1. So we get the coordinate pi over 4, 1. Then we're going to move on to pi over 2. Okay? What's tangent at pi over 2? Well, there it is, undefined. Then we move over to 3 pi over 4. Tangent's -1. Pi, 0. 5 pi over 4, +1. 3 pi over 2, undefined. 7 pi over 4, -1. And then 2 pi back to 0. Okay? So these are our coordinates. My board will cooperate. All right. So we're going to plot all of these points on our graph to get our tangent parent function. Okay? So 0, 0. It's right there. Okay? Then pi over 4, 1. Well, this is pi over 2, so pi over 4 is right in the middle. Pi over 4, 1. Now, at pi over 2, my function's undefined. That means I have a vertical asymptote there at pi over 2. And I'm going to graph the one at 3 pi over 2 while I'm at it. So there's tangents to asymptotes, and it's one period. Okay. And then 3 pi over 4, which is right here, -1. Pi is 0. 7 pi there. Then -1 and 2 pi. Okay, so using what we know from our rational function days, I have an asymptote. Well, I have these 2 points. They have to connect, and a function will follow its asymptote. So tangent starts here, goes up, follows its asymptote. Same thing here in the middle. Goes through the coordinates, follows its asymptote. This is the parent function for tangent. Okay? Now, the reason I haven't done anything with tangent with you guys yet is because it's ugly. I personally don't like graphing tangent. Okay? But I'm going to show you a little bit of a shortcut to help you out. Okay? So what I'm going to do currently is I'm going to draw the parent function for sine over tangent. Okay? So the 5 key points for sine are 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. So this is the parent function for sine. And if you notice something right away, that sine and tangent share the same zeros, where sine is 0, tangent 0. And where sine has its maximum or a minimum, tangent has an asymptote. So this is why I always tell my students, if you can graph sine, you can graph tangent, because they're basically the same function. The only difference is that when you're graphing sine, you have maximums and minimums, but when you're graphing tangent, that's where your asymptotes end up. Okay? So basically we're doing the exact same thing.